Okay, thanks a lot, Tamara. That was a very nice introduction to this this whole affair. I feel like I'm on the David Letterman show with this microphone. The title of this is basically we want to do a winter recap, take a look at where things are right now and what are the prospects for summer coming up. And if I can make the buttons work here, okay. This is just some of these are just by way of reminder, and this is going to be posted later on, so you can look at them in more detail. So there's a few things I might either skip over or go through kind of fast. It's more so that they're sitting there for people to look at in a little bit more leisure later on. So this is just a reminder of what this is about and the agenda. And so what is the Great Basin? What are we considering to be the Great Basin here? It basically, you can define it hydrologically or biologically, and those are a little bit different definitions. Generally end up with a shape that's something like this, and either way, it's got the state of Nevada is a major component of that, and then how much of the surrounding states and a little bit of Nevada that's not technically in the Great Basin, but it's sort of honorary Great Basin, I guess. So, or what goes on in parts of like the southern, like Las Vegas, do affect what happens in other parts of the Great Basin. So it's just a little bit of the motivation. And I think the one thing I wanted to bring out here is this third point, is the meeting isn't really about climate change, although that's all we hear in many ways about climate, it seems. But it's really about climate in its generality, and that's been our long-term interest. That's the reason for the climate centers, reason for these climate science centers, and somewhat the LCCs is the changes that we're expecting. But the everyday monitoring of climate and its quasi-operational components and practical implications and so forth are the prime concern. But if there are slowly changing conditions that are a factor, or they may be changing not so slowly or episodically, those are certainly suitable topics because they enter into the management and monitoring issues. So a lot of the things I'm describing here are products and tools that are available at or through the WRCC web pages. We have another set of pages that are being developed by Britta Dauder here, who's in the back row, as part of this Department of Interior Southwest Climate Science Center. And we're always looking for your help in making this information more accessible, more useful, and more usable. I mean, it has a kind of a practical side to it in a big way. So one thing I'll mention just briefly, Nina, who is standing back there by the door, Nina Oakley, has put together something in conjunction with Farm Services, with Clint sitting here in the middle. Climate and weather dashboard. She's going to describe this in more detail. This is I don't expect you to read this, but there's two sides to it. Sort of what's it like right now, what's led up to today, and then on the right-hand side there's a page full of stuff about the future, from starting with tomorrow on to as far out as we think we can see. And there's another dashboard that we're putting together too as part of the Southwest Climate Science Center for climate monitoring. We're trying to set this up for to work for the whole United States. So it's got a component for the Southwest, and I think this can be replicated in other parts of the country, and then a piece of it that will work for the whole country, and that this could be borrowed by other parts of the Climate Science Center program. So, since the last time we met, I'm just going to be stepping through a bunch of things that have happened with climate. Okay. So starting, we had our last meeting in October, so I thought I'd pick about the last 6 or 7 months or so. We're just a little bit later. We try to hold these meetings in the spring and the fall because people are busy in the summer, and they have a hard time getting to meetings like this, especially the people we're trying to reach. So sometime in April or May is before field season usually starts, although that's weather dependent, obviously. So this is the percent of average precipitation, and I kind of have to show the whole West on these because the Great Basin, when we divide up the West into little pieces like the Southwest or the Northwest or some other region, we're always on the boundary of those, and so we have to show a bigger area. So starting in October, we had precipitation. We had a lot of precipitation up in the northern parts of the western states, and then an early winter system that came through in the southern Great Basin here. And anything that's red here is on the dry side, on down to about 5%. Anything that's on the wet side, if it's up in the purple, it's 200 or 300% of average, okay? And so this is October, and then in November we started to get some storms that came in, especially later in the month in the Sierra, and we got the usual type of storms, the winter storm season that sets in the northern Great Basin. Going into December, it was a pretty wet month across the entire Great Basin. One little pocket here that didn't get as much, but it was quite a wet month, and around most of the west, and even down into the desert southwest. Then into January, it pretty much dried out in the western side of the Great Basin. You'll notice that there are, in the eastern part of the Great Basin, over around Ely and Elko and maybe into Utah, that there were places that did get near average precipitation. This is January going into February. There was one little pocket, or two maybe, of above average, but most of it was below. March was below, except for this looks like is one station that might have gotten blessed with a stray rainstorm or something. So that's the last 6 months in terms of precipitation. If you look at the temperatures for that same period, that's October was above average over most of the Great Basin. November was above average over most of the western U.S. December, again, continuing above average. The dividing line is between yellow, which is above, and green, which is below normal in temperature. Then the winter came, and we had these, the precipitation shut off. We had sharp inversions, somewhat like we have this morning. You can see the smoke layer out there. And had very sharp inversions, and so it got quite cold down near the surface in two main pockets. One is in the Great Basin in Nevada, and then over near the Wasatch, Salt Lake City, and on up to Logan, and then on down into further south in Utah. A lot of air quality problems that came up because of this, and that kind of hung on into February, especially more over in Utah on the eastern side of the Great Basin. But it's still a cool month. March was more above average over much of the Great Basin. In the eastern side of the United States, you can see a hint of it right here, was quite cool. It was one of the coolest Marches on record in parts of the eastern U.S. So it's a good time, since the year just ended, to take a look at the west. So this is looking at these 11 western states here. This is the temperature history of the western United States since 1895 based on surface data. And you can see it wanders around here. It always goes up and down from one year to the next. And the blue is a 11-year smoother. I've run over it to smooth it out a little bit. It's got some decadal scale variations here. Starting about the mid-70s, there was a sort of a long-term rise up to about the late 90s. After that point, it kind of smoothed out, and it stayed about the same for around a decade or so. Then we've just gone through a period here of about 4 years that have been what we would call cooler than whatever normal is now. It's come back down about halfway to where it was, so it's cooler than this, but warmer than that. And then finally, the last year, the temperature really popped up again in 2012. You'll see this in a second. And it was the second warmest on record to 1934, which is still the standout year in the western states. So just a little recap of the past, since the year 2000. These are the temperature departures for the United States. Red is above, green is below. And starting with the year 2000, these are calendar year, so it's all 12 months. And you can see during the early part of the first decade of this millennium, the temperatures were generally above average, especially in the western states, on up through about 2007 or so. Then we started to see a kind of a cool down in the Midwest, extending to the west. It repeated in 2009. If we step forward and repeat a couple of them, so there's 2008, 2009, 2010. It was a little bit more on the warm side, but still some cool or near average pockets. 2011, still some cool places. Then 2012 was the warmest year in the United States by far in its history. One other thing is, this entire time, the Southwest has kind of continually stayed above average, even if it's been cooler up to the north. So let's take on into April. We just finished April, so here's what April looked like. Again, another dry month, mostly in the western Great Basin, a little bit more precipitation on the eastern side and over into the Wasatch. And they got enough precipitation in Colorado and Wyoming and Utah that you'll see after a little bit here that the flow projections for the Colorado River went up, although not really dramatically, but it did go up some. And the temperature was above average in this part of the Great Basin and below average in the kind of northeastern part. So just recapping a little bit more, first of all, October, November, December, precipitation on the above average side up north here and along the west coast, but not very far inland. It just shut off pretty quickly, almost in the distance you can see out the window there. And then January through April, the first 4 months, there's a lot of red on this map. It's pretty hard to find anything that's in the bluish color. And then averaging it all together, this is this is temperature. So the first part of the water year was above average, and the second part generally was below average on the right-hand side, the last four months or so. If you lump it all together, October through May 1st, these maps are on our website. They're updated every day. There's about 8,000 of them or so that we update. They go back several years. And then we have the last few days to few months. So the percent of average for the water year so far since October 1st, generally in the red zone. Again, over in the eastern side of the Great Basin, a little bit less so. And Scott, this sort of relates to some of the conversation we've been having, about can patterns like this persist for hundreds of years? It's kind of an interesting paleo question in the interpretation of paleo records. And the temperature side, a little bit more on the above normal side here and below normal average over that period since. So the last 3 water years in a row here, here's the year before last, ending September 2011. We had a really wet water year that extended quite a ways on down through most of Nevada into the northwestern Arizona. This is ending 2 years ago, ending last September. This is the water year, which is quite a dramatic shift from that one. And then adding on this year, another dry year, and just backing up a little bit, you can see some pockets here in the eastern side of the Great Basin and a little bit on the southern side. And again, this year. So it's not uniformly dry, but mostly dry, and a little bit more on the western side of the Great Basin. Okay. So we have a little thing called the Nevada Climate Tracker, and there's a California Climate Tracker I'll show you in a second too. And it just takes, using PRISM on a 4-kilometer grid, what the temperatures have been over the state of Nevada since 1895, and this is the annual temperature for the water year. So this ends in October. So it's a 12-month period, but it ends in October. And the one that ended last year, we've had a recent warming here of maybe 20 years or so, where it's been above average. For the averaging period here is 49 to 2005. So it's the second half of this is the reference period. That's why it's so much below normal, because it was below the reference period mean in the early part of the record. But that period was on the above average side. And then since that point, this is October through March. All the October through March is on record. It's been in average over the state of Nevada, a little bit on the plus side. Looking at precipitation for the state, water year precipitation, we came off that really wet year. There's last year. This is a full water year, so this ends last September. And then adding on the water year to date, I didn't have update yet through April, but through March, October through March, maybe 2/3 of average for the state average as a whole. If we look at the Sierra Nevada, we have an analogous thing that breaks down California into pieces. It's something we'd like to do for the state of Nevada, but we haven't had the resources to do that yet. This shows the water year to date. So this is October through April, comparing all other October through Aprils back to 1895 for the state, for the Sierra Nevada. It's about a 400-mile stretch. It goes from north of here to well south of here, with a smoother here, this orange line in the middle. You can see we've had more high values and more low values here in the last 60 or 70 years or so. We've had a lot of ups and downs, tremendous amount of variation from the very highest to the very lowest. And if you look at, there's the winter 2 years ago, here's the winter last year and the winter this year, they're both about 2/3 of average. And if you look at January through April, since the start of the calendar year, for that same area, First of all, there isn't a heck of a lot of trend, by the way, in these. There's a little bit. It's really hard to detect statistically a trend when it's such a noisy time series. It's got so much up and down. But here's the current year, and you can see we're way below any other year in the last 120 years or so. And so we've taken using PRISM on 4 kilometer pixels and looking at each pixel over the western states and finding out what its rank has been in the last, I guess that's about 118 years or so. And anything in this color right here is the record driest. Anything in that color is in the lowest 10%. And there's a lot of lowest 10%. And there's a lot of the area in California, Sierra Nevada, western Nevada, parts of Oregon, even up into Washington, and a little bit in Montana, Idaho, and Wyoming. That's the lowest it's ever been for these 4 months. So we did have a good start to the year. That did help. If we didn't have that, it would make a difference. So these overall patterns do matter, but really, if you think about, since we're trying to see what the applications are of this information to all kinds of problems and issues and just understanding how things work, really the way in which climate unfolds each and every day makes a difference. And so I just want to show you a few examples here. Part of this talk is about where you can go to get information. And the overall point stays the same, but there's some specifics, and sometimes the specifics really matter. They matter for things like disease of birds or wildlife or fish, for the way plants develop, for insects, all kinds of things. So here's one example of something you can get from the Climate Prediction Center, which is in DC. It's part of the National Weather Service. And I've just picked some major cities here. It just goes back 365 days. These are updated every day. This is Boise, and anything that's red shows a day that's above average. There's a seasonal cycle there, and then the departure from it. And on the right-hand side is Ely, same kind of thing. And this is a 30-day mean of what's shown up here to get some trends that last a little bit longer. And basically is above normal in Boise for most of the winter until this period here in January. We had a couple of really cold episodes, some cold and warm episodes ever since. There hasn't been really an extended period of above or below in the spring so far. Pretty much the same story in Ely, although it was a little bit more intense there on the cold side. And if we continue on to, this is Salt Lake City. Again, you see this period here where it was warmer or cooler than normal in the winter, and it kind of stayed that way, persisting into February and maybe on even the parts of March. It still hasn't gone away. We're still getting some of these inversions, and a kind of a major period there where it was below normal. Even though the general period here for the last year was above normal, that's what that green line shows. Going down to Las Vegas in the southern part of the basin, that's their attempt at a cold spell. I think water freezes in Las Vegas at about 40 degrees. So, and then kind of coming back around, this is Bishop. And Bishop has had some cool periods here, but it's been a little bit warmer because it's a little bit more toward the southwest, what I was showing you earlier. So that's one style of that you can get. And they also produce a precipitation accumulation, which you can get for the last 365, 90, and 90 and 30 days. And this is the accumulated precipitation starting last year. Boise, generally below average that whole time. Over in Ely, it started out below, but in August, they had quite a bit of precipitation. And the effects of this precipitation, they can linger for quite a while through various kinds of biological mechanisms. And so they had a kind of a wet August as part of the late monsoon period, and then averaged over the last year or so has been a little bit above average. And there's each and every precip episode on the bottom there. Here's Salt Lake City, which has been generally below average, but really if you have to look at the slopes on these. If the slope of the accumulation is about the same as the slope of the climatology, it means they're getting it at a climatological rate. And Las Vegas, due to a couple of big rainstorms in the summer and into the fall, that's all it takes there to be above average. And whether they're above or below average in Las Vegas is sort of dependent on whether they do or don't get a couple of big storm episodes. And then here's Port Bishop, which looks like it's had a part of an episode here and a couple of days of rain here, and then it's pretty flat for the rest of the time. And we see this repeatedly along the 395 corridor. So there's one other style which you can get from the Weather Service, a very nice form of presentation. This is from the Reno office for the Reno airport. They update this every day, and you can get it on a water year, calendar year, or monthly basis. So this is the water year starting last October. The long-term climatology here in the green band. Here's the record high and the record low each day. You can see they get closer to the means here, and there's more spacing of the records on the plus and minus side in the winter months because there's more variance then. And you can see we haven't really been very much close to record levels in Reno this whole time, pushing it here just recently, but and it's been above normal at night. And then there's the precipitation that we had in the fall, and it kind of flattened out, and here's the long-term accumulation starting in October. And so far we've had 9.4 inches of snow. It's measured right over there at the Weather Service office. And we have a couple people here from the Weather Service today sitting in as well. So, and here's another example from Elko. You can go over there and get that, and it shows each and every day. And the point of showing this is that, you know, we can sit in our air-conditioned and heated rooms and homes and so forth, and we're sort of buffered from all of this. But anything out in the natural systems that people are managing and watching and trying to understand, everything that happens on this chart has some kind of effect in biology. You can, it's guaranteed that every day on here, even if it's a sort of an average-looking day, is having some effect on some plant or insect or animal or system out there someplace, out the window here. And it's just, what is that? And so unless we record it, we can't untangle it later on. And here's the precipitation history and the snowfall history. They're running a little bit above average actually in Elko for snow, 42 inches. And this is Tonopah, just to give another example of this. And they don't have a snowfall record there, but here's their temperature record. And then here's their precip record. They're really coasting on they had a big event in October, but it's been actually pretty dry ever since because the slope is so different from the climatological slope. And you can also run these on our own system here at WRCC. We have a lot of stations, all the ones that are in the red dots here. That's Nevada and Utah if you can't make it out. And showing each and every day's max and min temperature, the long-term climatology. This is based on a kind of a short climatology, so it's not real smooth. And then what happened last year, this is at Smoky Valley, which is sort of in the middle of Nevada. And one other thing that we have another tool that you can look at freezing levels because we have mountains in the Great Basin, and what goes on in the mountains has a lot of effect in the valleys hydrologically. There's also biological issues, and what's the freezing level doing? It's a measure of what the overall temperature is, but whether you're above or below freezing is a really critical threshold in nature for biological systems. So I don't expect you to memorize these, but you can go in and run these off at your leisure. And I've just got on a traveling, so I started last April when we had our last meeting, April through March. And these are records that go from 1948 on the left to this year. These are updated about every other day, and they go back to 48. And so plus here means the freezing level is higher than usual. Minus means it's lower than usual. Plus means warm. Minus means cold. So for example, you can get a pretty quick reading on like October, November was quite warm, had a high freezing level in other words, and you can't make out the numbers here, but these are in thousands of feet. You can put them in meters if you want. And then it kind of cooled off in January and had a series of Februarys that have been kind of cool. This is over about the Ruby Mountains or so. But March was above, okay? And we have noticed a lot of high freezing levels in March. Over the last 25 years. So that's a lot of implications for how snow melts, how quickly it melts. Does it hang on, or does it melt a little bit early? What goes, the spring is when sort of the winter gets resolved, and the effects of winter start to show up in the spring. So this melt season, the season that we're in right now, has a lot of, it's a connector between winter and summer. They have a thing at the California Department of Water Resources called the 8-Station Index. It's these 8 stations right here, which have a long-term record going back to about 1922 or so. Here's their accumulation on a typical year, water year. It averages nicely enough, 50 inches exactly. And here's the year before last, 72 inches. So it was really wet all winter long and way late into spring, and spring just hung on forever, it seemed like. Last year, there's last year right there, we had that really dry start, if you remember, and then we kind of caught up toward the end. This year, we came out of the starting gate really rapidly, then it just kind of petered out. They had a little bit of precipitation here for these sites up here in March and April, and we've gotten to where we were last year, but by a whole different route this time. And one of the points here is the route matters for certain kinds of problems. For other kinds of issues, maybe it doesn't. For water supply managers, they might like to know, you know, what's it like by April 1st, no matter how it got there. But there's decisions made along the way, like they got to go to get a bank loan for raising crops and so forth. If you don't know, you know, and that's usually in February or so. So there's a big difference here of what your prospects might be for the summer.